about Huntsman's polyurethane technologies. Let's discover this solution for your next composite challenges. My name is Hubert Reitberger. I'm currently working for Huntsman Polyurethanes as Automotive Composite Product Manager, and I'm based in Deggendorf, South Germany. Huntsman is a global manufacturer of differentiated chemical products and has a revenue of approximately $6 billion in 2020. 9,000 employees are spread over 70 manufacturing, R&D, and operational facilities. We are serving more than 15 industries globally, and this through 4 different divisions, which are textile effects, performance products, advanced materials, and polyurethanes. Today, I will focus on composite resin systems for battery housings, composite resin systems for interior structures. I will give an insight on sustainability, our commitment in that for composites. And after concluding, I will answer your questions, but feel free to type them already during the presentation into the right box on the Q&A box. My colleague Paul van Grimde, who is Technical Manager for Composites, will already start to answer your questions to ensure we can really answer them during these 20 minutes. Huntsman Polyurethanes offers a broad range of composite solutions that reduce weight, enhance performance, improve safety, and optimize the process for the automotive industry. The product families Rimline and Whiterox are used in different types of applications, such as interior structures, leaf springs, battery housings, and underfloor and drivetrain protection. For battery houses and underfloor structures, we help solving the major safety, mechanical, and thermal requirements at low weight with solutions suitable for mass production. And we further can help reducing weight with the integration of lightweight core materials, which are compliant with the overall production process. Interior structures with high panel stiffness can be made at affordable costs. High productivity and low waste are essential for such kind of sensitive application. It offers high design freedom and process flexibility, which is making your life easier. Let's move to battery houses and underfloor structures first. Of course, there are already several designs developed by OEMs and tiers. They use various materials such as steel, aluminum, composites, or even multi-material designs. In this section here, we are focusing on long fiber reinforced composite solutions. There are 2 potential concepts which are meeting the safety and mass production requirements. Concept 1 is a monolithic layup with the addition of an intumescent function on the surface. Fast curing solutions are used in combination with fire-resistant additives or textiles. These resins are proven for mass production and benefit from their freedom to adapt fire properties as needed. Concept 2 is about a sandwich composite panel design with lightweight core materials. Through the sandwich design, the bending and torsional stiffness can be increased on the one side, but the thermal insulation on the other side advances the thermal management. Manufacturing can be done via resin transfer molding, wet compression molding, or composite spray molding. Let's look into concept 1. Our Vitrox RTM resin's ductility and toughness, in combination with its strong fiber matrix adhesion, results in very damage-resistant parts. On top of that, Vitrox RTM benefits are a low viscosity and a tunable injection time, which makes it suitable to produce large parts at high fiber volume fractions. With the patented built-in snap cure catalysis, only a short cure time is needed after injection, so parts can be demolded fast. Together with the built-in internal mold release, this snap cure makes the resin system really mass capable. The Vitrox RTM Snap Cure PU systems are designed with a glass transition temperature of about 130 degrees C, so they have the thermal resistance that is needed for the use in semi-structural and structural applications. For concept 2, rimline foam core systems are used in combination with the previously mentioned Vitrox RTM resin. Rimline FC foam cores are used between two rigid face sheets made with Vitrox RTM resin to create a sandwich panel. Rimline FC can be offered at a large density range from 150 to greater than 300 kilo per cubic meter. It is molded directly into the final shape by either injecting or pouring it into the closed or open mold. Both thin, thick, large, and complex core shapes are possible. The formulation has a good flow characteristics and hence filling is excellent, even at limited foaming pressures. Productivity is high thanks to the fast cure and low tool cleaning needs. Out of the mold, these cores are ready for a subsequent resin transfer molding or wet compression molding process and to show an outstanding property balance for reliable process performance. These, for example, are a low resin penetration under high molding pressures and temperatures, and a good resin adhesion between the sandwich skin and the pre-cured polyurethane core. As an alternative to the Rimline FC technology, a novel sandwich design concept is offered by the composite spray molding process in combination with Vitrox HC resins. Here, a flat thermoplastic core material sheet is used, typically a polycarbonate honeycomb core, over which glass or carbon reinforcements are placed. Then Vitrox HC resin is sprayed over it at both sides. This flat and wet assembly is transferred then into a 130 degrees C preheated tool for a wet compression molding. Vitrox HC resin has a tunable reactivity, which makes it possible to adapt to a wide range of molding conditions. Complex geometries with high part and function integration can be made, thanks to the thermoformability and stretchability of the core material. This results in parts with high stiffness to weight ratios. It offers the possibility to mold complex shapes without preforming and to integrate multiple parts in one large part. All of this at a limited tooling cost and minimal investments due to the low molding pressures. This process today mostly is used for the production of load floors using paper honeycomb cores and glass fiber mats. Which brings us to the composite resin systems for interior structures. Rimline HT+ polyurethane resin systems are developed for the composite spray molding process of load floors, but they are suitable as well for other applications like roof modules or body panels. The design and production challenges like affordable productivity, low tool cleaning needs, low waste, and low rework do require the resin system having a long spray window while keeping cure times short. An internal mold release is a must, but carpet bonding without surface preparation is required. Our Rimline HT+ resins provide design freedom through a very good edge filling capability with the reduced need of extra edge spraying. Simple and complex parts with deep draws and high paper compression can be produced. The resin provides a better productivity with its 100-second spray time to operate large or multi-cavity tools, while keeping cure times short at 35 seconds for simple or 60 seconds for complex parts. A high number of releases without tool cleaning is possible, and the patented strong paste formation when sprayed results in a cleaner production as the resin is drip-free. Rimline HT+ has spot-on properties. Its high mechanical integrity can be found in high bending strength, high stiffness, and high skin-to-core tensile adhesion strength. Changes in process like spray time, spray density, or demold time have little impact on final part properties and make the resin wide and easy to process. A good carpet adhesion strength without extra surface preparation reduces the number of production steps and enhances the final product durability. Low volatile emissions, low windscreen fogging, and low odor are without to say for interior applications. As previously mentioned, this technology can be moved from interior semi-structural to structural applications by using thermoplastic honeycomb cores and glass fiber non-trim fabrics or recycled carbon. Finally, I'd shortly like to talk about our sustainability commitment in composites. Sustainability is a main driver for our daily work and visible through our standards and ratings. We are working on renewable raw materials by increasing our bio-based feedstock. For our PU resins and core foam technology, we are evaluating recycled and bio-based polyols to work towards a 50% circular content. And finally, our vision is to limit our carbon footprint by reducing our energy consumption, as well as enhancing our water and waste management. To sum up, today we talked about Huntsman polyurethanes, how we can help you solve your automotive challenges with regards to interior structures, battery housings, and underfloor protection. Our composite solutions reduce weight, enhance performance, improve safety, and optimize your processes. I hope you enjoyed the presentation, and I would like to thank you for your participation. Now I would like to open up for the Q&A section. As well, you can reach us via email, so you can find my email account, but as well a general one where you can reach us in general. As well, you can visit us on our virtual booth. So, looking forward to your questions.
Hello, Hubert. We already have quite some questions in the chat box and also already answered. There is one.
Mark, I think I can't hear you.
Wait a second. Do you hear me now?
Unfortunately, I can't hear Bart. So I think the first question is, how do you manage the system's reactivity? If that is related to the SnapCure technology, for example, we can do that via the catalyst level on the hindering, but as well there is the possibility on temperature, on the chemicals, but as well on the moldings. In that sense, we have quite a wide window. So as well, there is the possibility to change the mix ratio, which as well changes a lot in reactivity. The next question.
I think you should be able to hear me, Hubert. The public hears me.
Is there any recycling system in place to recycle the thermoplastic PU-based composite parts? Or is it all burned nowadays? Will you set this up with industry? Yes, indeed. There is a lot of work going on towards recyclability of these. So currently there is possibilities to either shredder and powder materials, to use them in other applications. You can as well burn them, and if there is glass fiber, for example, in the system remaining, this can be used then as well for concrete applications, as for example. But there is other things around on recycling or getting back the polyols into slightly higher viscose materials, which then can be introduced as well in other applications again. Which cycle time could you reach for automotive sandwich trim parts? What is the curing time of this PU foam? Generally spoken, this is related as well on the density, but as well on the shape of the part and how complex it is. If you think of very, very thin and large parts, you can mold them within a few minutes. And depending as well on how you produce them further or use them further. So something like 5 minutes, 4 or 5 minutes. Okay. I think currently there are no further questions. Unless, Bart, do you see some further? If not, I would like to thank you again for your participation and hope you enjoyed it. There's one further. Battery boxes today are built in metal, mostly aluminum. Why should we use composites for this application? There is several things which we can think of. The possibility the possibility using composites is is enhancing the part stiffness. You can reduce the weight a lot, something like even going down to 40%. And for this, a composite application is a quite nice opportunity. As well, we have quite some design freedom, and you can do a component integration, which sometimes is more complex, or which is more complex for metal or aluminum designs, where you have to do the joining technologies. Okay. I hope I could answer your questions, and I hope you enjoyed it. Thank you very much, and see you next time. Thank you. Bye-bye.